Good morning students. Today we will discuss the continuing part of real numbers. Now let us take revisiting irrational numbers. So revisiting irrational numbers. Revisiting irrational numbers. First, we take irrational number. Irrational number. Irrational number ಅಂದರೆ ಅಭಾಗಲಬ್ಧ ಸಂಖ್ಯೆಗಳು. A number which cannot be expressed in the form of P by Q is called irrational number. Is called irrational number. Here irrational number. Here P comma Q belongs to Z, where Q is not equal to 0. Once again, irrational number. A number which cannot be expressed in the form of P by Q is called irrational number. Here P comma Q belongs to Z, comma Q is not equal to 0. Next, theorem 8.3. Let P be a prime number if P divides a square, comma, then P divides A, where A is a positive integer. Once again, theorem 8.3. If P be a prime number, ಒಂದು ಸಂಯುಕ್ತ ಸಂಖ್ಯೆ, P be a prime number if P divides a square, then P divides A, where A is a positive integer. P ಏನು ಮಾಡುತ್ತೆ? A square ಅನ್ನು ಡಿವೈಡ್ ಮಾಡುತ್ತೆ. Then P ಕೂಡ ಏನು ಮಾಡುತ್ತೆ? A ಅನ್ನು ಡಿವೈಡ್ ಮಾಡುತ್ತೆ. A ಏನಪ್ಪ ಅಂದ್ರೆ ಅದೊಂದು A is a positive integer. Next, coming to the next point, theorem 8.3 or example 8. Prove that root 2 is an irrational number. Example 8. Example 8. Root 2. Prove that root 2 is irrational. Root 2 is irrational. So proof. Let us assume that that root 2 is rational. Okay, children. Now let us assume to the contrary that root 2 is rational. So root 2 is equal to P by Q, where P comma Q belongs to Z comma Q is not equal to 0 and P comma Q is equal to 1. So there is no other than common factors. There is no common factors. There is no other common factors of P and Q rather than 1. Common factors P and Q other than 1. Once again, so P comma Q is equal to 1. So there is no other common factors of P and Q other than 1. So once again, P by Q, root 2 Q is equal to P, root 2 is equal to P. So squaring on both sides, we get root 2 Q whole square is equal to P square. So root and squares are cancelled. Remaining number is 2. Q square is equal to P square, equation 1. So this implies that 2 divides P square, then 2 divides P. Once again, root 2 is equal to P by Q, root 2 Q is equal to P, squaring up both sides, root 2 Q whole square is equal to P square. So square root cancelled, 2Q square is equal to P square 1. So if 2 divides P square, then 2 divides P by theorem 8.3. So now let P is equal to what? The root 2 number is there, 2m. In equation 1, substitute P. So 2Q square is equal to P square. So 2Q square is equal to 2m whole square. 2Q square is equal to 2 2s are 4. We write 2 into 2, m into m square. So 2 get cancelled. Q square is equal to 2m square. This implies that, so again, Q square 2 divides Q square Then also 2 divides Q by theorem 8.3. So 2 is the prime factor for both P and Q. Therefore 2 is the common factor. Therefore 2 is the common factors for both P and Q. Once again, P is equal to 2m. Substitute P in equation 1. Substitute P in equation 1. 2q square is equal to P square. 2q square is equal to 2m whole square. 2 into 2 m square. 2 get cancelled. Q square is equal to 2m square. So 2 divides Q square and 2 divides Q. So therefore 2 is the common factors for both P and Q. This contradicts that. Therefore this contradicts that there is no common factors of P and Q. Once again, this contradicts that there is no common factors of P and Q. So therefore our assumption is wrong. So root 2 is an irrational. Root 2 is an irrational. Once again, first we take root 2 is equal to P by Q, where P comma Q belongs to Z, where Q is not equal to 0, and P comma Q is equal to 1. Substitute ಮಾಡಿದಾಗ ನಮಗೆ ಏನು ಬರುತ್ತೆ? P square is equal to 2m square ಬರುತ್ತೆ. So ನಾವು ಏನು ಮಾಡ್ತೀವಿ? 2 divides P square and 2 is also divides P by theorem 8.3. So 2 is the common factors for both P and Q. Next, P is equal to 2m ತಗೊಳ್ತೀವಿ. 2q square is equal to P square ಆಗುತ್ತೆ. Therefore Q square is equal to 2m square. ಅವಾಗಲೂ ಕೂಡ ಏನಾಗುತ್ತೆ? 2 divides Q square and 2 divides Q by theorem. Therefore 2 is the common factors for both P and Q. This contradicts that there is no common factors of P and Q. So our assumption is wrong. So root 2 is irrational number. Next, we take one more example. Exercise 8.3. Exercise 8.3. First problem. Prove that root 5 is irrational. Root 5 is irrational. Exercise 8.3. Prove that root 5 is irrational. Prove. So we can prove that root 5 is irrational. Let us assume to the contrary Do you understand? First we take prove that root 5 is irrational. First we take our assumption. ಏನಾಗಿರಲಿ ಅಲ್ಲಿ ಭಾಗಲಬ್ಧ ಅಂತ ಸಾಧಿಸಬೇಕು ಅಂದ್ರೆ ನಾವೇನು ಫಸ್ಟ್ ಏನು ತಗೋಬೇಕು, ಅಭಾಗಲಬ್ಧ ಸಾಧಿಸಬೇಕು ಅಂದ್ರೆ ಭಾಗಲಬ್ಧವಾಗಿ ತಗೋಬೇಕು. ರ್ಯಾಷನಲ್ ಮೀನ್ಸ್ ಭಾಗಲಬ್ಧ ಅಂತ. ಲೆಟ್ ಅಸ್ ಅಸ್ಯೂಮ್ ಟು ದ ಕಾಂಟ್ರರಿ ದಟ್ root 2 is rational. So root 5, once again let me make this spell, root 5. So root 5 is equal to p by q, where p comma q belongs to z, where q is not equal to 0, p comma q is equal to 1. So there is no other common factors of p and q other than 1. Therefore there is no other common factors of p comma q other than 1. So there is no common factors of p and q. p ಮತ್ತು q ಗಳಿಗೆ ಯಾವುದೇ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ಇರುವುದಿಲ್ಲ, ಒಂದನ್ನು ಹೊರತುಪಡಿಸಿ. ಸೊ ದೇರ್ ಈಸ್ ನೋ ಅದರ್ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆಫ್ p and q other than 1. Once again, root 5 is equal to p by q. So root 5 q is equal to p. So squaring on both sides, squaring on both sides, we get, you observe carefully, root 5 q whole square is equal to p square. Squaring on both sides, square root cancel, the remaining number is 5, q into q, q square is equal to p square. Equation 1. So if 5 divides p square, then 5 also divides p. 5 divides p by theorem 8.3, by theorem 8.3. Once again, root 5 is equal to p by q. p comma q belongs to z, where q is not equal to 0. p comma q is equal to 1. There is no other common factors of p and q other than 1. So root 5 is equal to p by q. Root 5 into q is equal to p. So squaring on both sides, we get square root cancelled, the remaining number is 5. q into q, q square is equal to p square. Equation 1. So this implies that if 5 divides p square, then 5 also divide p by theorem 8.3. Let p is equal to 5. So p is equal to, substitute p value in what? As equation 1. So equation is what? 5q square is equal to p square. So 5q square is equal to p square. So 5q square is equal to 5m whole square. 5q square is equal to 5 5s are 25. 25 can be right. 5 into 5 m square. Yes students, equal to 5m square. So this implies that is what? So q square 5 divides q square, then 5 also divides q by theorem. So 5 is the common factors for both p and q. Therefore 5 is the common factors for both p and q. So this contradicts that there is no common factors of p and q. Our assumption is wrong. Therefore, root 5 is an irrational number. So this contradicts that there is no common factors of p and q. Therefore, our assumption is wrong. Therefore, our assumption ನಮ್ಮ ಊರಿಗೆ ಏನಾಗಿರುತ್ತದೆ ತಪ್ಪಾಗಿರುತ್ತದೆ. So root 5 is what, dear students? So root 5 is an irrational number. Once again, so root 5 is equal to p by q. So there is no other common factors of p and q other than 1. Root 5q is equal to p square, squaring on both sides. 5q square is equal to p square. 5 divides p square and 5 also divides p by theorem 8.3. Let us assume p is equal to 5m. Substitute p value in equation 1. 5q square is equal to p square. 5q square is equal to 5m whole square. So 5 get cancelled. Q square is equal to 5m square. So this implies that 5 divides q square, then 5 also divides q by theorem 8.3. Therefore 5 is the common factors for both p and q. This is not possible. So this contradicts that there is no common factors of p and q. Therefore our assumption is wrong. So root 5 is an irrational number. Example 10. Show that 5 minus root 3 is an irrational number. So 5 minus root 3 is an irrational number. So we take one more example. Example 10. Show that 5 minus root 3 is irrational number. Example 10. 5 minus root 3 is irrational. Proof. Let us assume to the contrary, that 5 minus root 3 is rational. So 5 minus root 3 is equal to P by Q, where P comma Q belongs to Z, Q is not equal to 0 and P comma Q is equal to 1. So here there is no other common factors of P and Q other than 1. P ಮತ್ತು Q ಗೆ ಒಂದನ್ನು ಹೊರತುಪಡಿಸಿ ಬೇರೆ ಯಾವುದೇ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ಇರುವುದಿಲ್ಲ. There is no other common factors of P and Q other than 1. So 5 root 3 is equal to 5 minus P by Q. Root 3 is equal to 5 minus P by Q. So root 3 is equal to, take LCM, Q ones are Q, 5 into Q, 5Q minus root 3 is equal to Q ones are Q, 5Q minus Q to get cancel P. So here 5Q minus P by Q is a rational number, but root 3 is an irrational number. Therefore this is not possible. This is not possible. Once again, 5Q minus P by Q is a rational number, but root 3 is an irrational number. This is not possible. Therefore our assumption is wrong. So 5 minus root 3 is a irrational. Once again, this one is rational number and root 3 is irrational number. This is not possible. Our assumption is wrong. So 5 minus root 3 is irrational. Dear students, we already told example 8 and example 10, and do remaining example 9 yourself, and we will continue the exercise 8.3 in the next class. Thank you. Once again, recall, today we discuss revisiting irrational numbers. So first we take definition rational numbers, and example 8, root 2 is a irrational, and exercise 8.3, prove that 5 root 2 is irrational, and example 10, show that 5 minus root 3 is irrational. So dear students, all these problems are completed, and the remaining example 8 yourself. Thank you.